Okay, we're looking at the test review for topic 5. So problem number 1 says this figure is a centroid. On your cheat sheet, it says that the centroid is created by medians, and it says that it also says the equations down at the bottom say that this longer piece of the line that cuts across is twice as much as the shorter piece right here. So that sets up an equation where the longer piece is equal to 2 times the shorter piece. You could also have this equation where you said that this piece, the short piece, is equal to half of the longer piece. So that's where this part comes from. 3x equals 6x minus 72. Either way, you're going to end up, whether you distribute this 2 or whether you divide it and get it like this, you'll end up with the same answer. Okay, we got to move all of our x's to one side of the equal sign and have all of our constants on the opposite side. So we subtract the 6x, becomes negative 3x minus equals negative 72, and we divide to get the x by itself. X equals positive 24. Problem number 2. This is probably the most complicated one on the whole paper right here. All right, we've got first off, we have an in-center. According to your cheat sheet, the in-center is created by angle bisectors. So that means this angle up here that's labeled 31, the one next to it right here is also 31. So that means this whole entire corner, all of this business up here on top, all together, is 62. Okay, that's going to be important later. This stuff right down here, because the in-center is created with angle bisectors, that means x plus 10 and 3x minus 20 are going to be equal to each other. That's where this equation right here comes from. All right, 3x minus 20 equals x plus 10. And again, we put all of our x's onto one side, and then we put all of our constant numbers on the other side. 2x equals 30, we get x equals 15. So if that is the case, then this right here is going to be 25. And this right here, since it was divided in half, is also going to be 25. Okay? That gives us this whole entire corner down here of the triangle is 50. So the question that's being asked, the question is asking about angle ZTU. That's this angle right down here. Angle ZTU is this one right here. Okay, so here's what I'm thinking. If we can find the whole entire corner, if we can find this whole thing, we can just cut it in half to answer the question that's being asked. Okay, we know also that every single triangle that's ever been created has 180 degrees on the inside of it. So if we can take 180 minus 62 minus 50, that would give us this green circle right here. That would give us that measurement. Okay, so that measurement ends up being 68. And our question that's being asked, angle ZTU, this one right here, well, that's just going to be half of 68. All right, our answer, angle ZTU, with my fabulous mouse handwriting here, it's 34. That's what we're looking for. Angle ZTU, 34. Okay, I will say that this problem right here on the review, much more complicated than the one that's on the test. Okay, the one that's actually on the test, much simpler than this, but you're still going to need to recognize when you have angle bisectors. You need to recognize when stuff is equivalent, and you still need to, you can't forget everything that we've learned before, like the fact that there's 180 degrees in every single triangle. All right, stuff like that will still come up every now and again. It's still going to be relevant. Go on now to problem number 3. It tells us that this picture is a circumcenter. I believe your paper says OA right here instead of OC, but here's the thing. The secret is it's going to be the same answer, okay? The circumcenter, it tells us on your cheat sheet, it tells us that it's equidistant from every vertex. So that means this distance from B to O, and this distance from A to O, and this distance from C to O are all exactly the same. All those lines that I just drew are all the same distance. Okay, so whether you're finding OC like it says on this or OA like it says on your paper, the answer is the same. It's 51 because it matches this one that's labeled. All right, this 24 and this 45, that's extra information. It's trying to throw you off. All you need to know is that the circumcenter is equidistant from each vertex, just like it says on your cheat sheet. So that's 51. 51. Problem number 4 is not found on your cheat sheet, so it's something that you might want to add to it. Okay? This is a mid segment on the triangle. It connects the midpoint of this side to the midpoint of this side. Okay? That right there and that right there are both midpoints. What that means is that this segment is half of the length of this segment. So if you took 2 of these, it would be equal to this. Or you could say that this side length is double the length of the mid segment. And that's exactly what this equation is. The side length is 2 times the mid segment. So we distribute that 2. And now we go through the process again where we put all of our x's on one side, all of our constants on the other side. We move over that 5x, becomes x minus 34. We move over that 34 and we get x equals 63. That's the answer we're looking for. Again, make sure you're reading what the question is asking for. The question is just asking for x. So as soon as we find that, we're done. Going now to number 5. A lot of people looked at number 5 and they decided to find the midpoint in between J and M. But that's not what this problem is asking for. This problem is saying that J is an endpoint, K is an endpoint, and M is the midpoint. M is the middle. Okay, so when we find the midpoint, the way we find the x and y coordinate is by taking the average of our two endpoints. So this negative 11 is the average of 7 and some other number that's going to go right there. This negative 6 in the midpoint is the average of negative 18 and some other number that's going to go on our answer. All right, so look at our x value. This right here is straight out of the formula for the midpoint. Okay, it just says the x value of our midpoint is the average of the two ends. If that is the case, you can say that the average is going to be negative 11. And that's the same thing as 7 plus some other number divided by 2. So to get that other number by itself, you multiply times 2, and then we subtract this 7 to get the x by itself. X equals negative 29. Okay, that's the number that goes right there. That's our x value of our final answer. All right, finding the y value is exactly the same process. Okay, we already know the average of the two y values is the midpoint y value. So that negative 6 is the average of negative 18 and some other number. Negative 18 plus that other number divided by 2. The process to get the number by itself, exactly the same. You multiply times 2, and then you get rid of this other thing. How do you get rid of minus 18? Well, you add 18. So we add 18 on both sides, and we get 6. So our final answer, negative 29, positive 6. All right, this next one is asking us to find the length of JK. That's the same thing as finding the distance between J and K. So if we're finding the distance, we have to use the distance formula. The distance formula is where you take those numbers and you find the difference between the x values, the difference between the y values. Okay, and it's that big old mess of stuff. You might want to add that formula to your cheat sheet, the distance formula. Add to your cheat sheet. Okay, and if we're doing that, it's going to be in your best interest to simplify stuff down. If you wanted to type this whole thing into the calculator, as long as you typed it in right, that would be a good answer. But it is so easy to mistype something when you have it set up like this. It's so easy to get mixed up. So it's going to be in your best interest to simplify things down as you go. Okay, you can turn it into 36 and negative 24 squared, or you can just put in the actual numbers themselves. But if you're going to go that far, you might as well just put it in like this. This right here down at the bottom, the square root of one number, is a lot easier to type in than the square root of all this stuff. But whatever you do, whatever you decide to do on your own, you end up with an answer that looks like this. Okay, that's the distance we were looking for. Go on now to number 7. In your notes packet, there are a couple of theorems we looked at called the perpendicular bisector theorem and the angle bisector theorem. And on all of those practice problems that had to do with those, we were always taking something that it gave us, and we said that it was equal to something else that it gave us. Okay, in the perpendicular bisector, it could have been the two distances were the same. It could have been that these angles were the same. That's what we have in this case. Okay, we just have to set up an equation where one thing equals the other thing. This equation right here, 8x equals 3x plus 25. You move that 3x over, and you divide to get the x by itself. This is not the end of the problem. The question doesn't care what x is equal to. The question wants to know, what is angle C? So we know that angle C is 8 times x. Well, for 8 times x, we have to take it, turn it into 8 times 5, and that's 40. That's what the question is asking for. That's the answer. That right there is the answer that it's looking for. Go on now to problem number 8. Problem number 8 is more of the same. Okay, this time it's an angle bisector. And according to our theorem, an angle bisector says these two distances should be the same. So we set up an equation where the two things are equal. 13x equals 10x plus 57. We move the 10x over, and then you divide by 3 to get x equals 19. I want to go ahead right now and skip down to number 12 because it's almost exactly the same. Okay, on number 12, we've got the same setup, an angle bisector. We know it's a bisector because this one and that one are the same. 2y equals 5y minus 7. Set them equal to each other and then solve this equation. Okay, the difference here is that your answer is not a whole number. Okay, that is possible. That is a thing that happens a lot. Okay, what happens here a lot of time, the reason this is on here, there are some students I've had before that would look at an equation like this with variables on both sides, and they could tell, they could just punch numbers into the calculator and basically guess and check if their answer was right. And they would punch in a bunch of numbers for the variable until they found one that was equal on both sides. That only works if you're finding answers that are whole numbers. Okay, this answer is not a whole number. It's 2.333 repeating because you got 7 divided by 3. Okay, make sure you know the algebra behind this and you can actually solve this problem for real. Come on back to number 9. Number 9, when I look at this picture, I notice that this picture represents an incenter. And the reason I know that is because all of these angles have been split exactly in half. Now, on your cheat sheet, it says that your incenter is created by angle bisectors. All right? Also, on your cheat sheet, the important facts say that the incenter is equidistant from each side of the triangle. So that means this line and that line and that line are all the same distance. Okay? All the same. And on your notes, I highlighted those lines to show you that they were all the same. What that does for us, we already know what GE and GF are in terms of x, so we can set them equal to each other if those GE and GF are the same. 2x minus 7 equals x plus 4. We move the x over, and then move the 7 over. X equals 11. So here's the thing. GE and GF and GD are all the same, right? They're all equal to each other. So that means if we can find this, if we can find that x plus 4, that will be equal to our answer, the one that we're looking for. X plus 4 becomes 11 plus 4, and our answer comes out to be 15. Problem number 10, this is just identifying what the points are, okay? This one right here, all of our sides are split in half, but they're not perpendicular, so that is a centroid, okay? All of those lines going across are medians, and medians meet at the centroid. These right here are all making right angles, but it's not connected, none of them are connected to the corners. So it's perpendicular, but it's not altitudes. So it must be perpendicular bisectors, which would make that a circumcenter. This right here, these are altitudes. It connects the corner to the opposite side and it makes a right angle. It just goes from the corner straight down and it makes a right angle. That would be altitudes, and that means this is the orthocenter. These lines right here in the middle of this one are angle bisectors. If those are angle bisectors, that means this point where they meet is the incenter. These lines right here, okay, this line I was just talking about it a second ago on this problem here, we've got a line going from the vertex straight across to the other side and it makes a right angle. That would be an altitude. This line right here goes straight from the corner to the opposite side and it splits it in half. That would be a median. You notice that this one is a right angle, but it doesn't split it in half. This one splits it in half, but it's not a right angle. That means neither of these is a perpendicular bisector. A perpendicular bisector would have both. It would be a right angle and it would split it in half. All right? So an altitude, a median, and a perpendicular bisector are all pretty similar to each other, but they're not the same. That's why you need to use the cheat sheet to make sure you can differentiate the things, okay? The cheat sheet has all of that stuff written down so that you don't have to remember it. Go on to this problem right here. This problem tells us the perimeter of the big triangle on the outside is 100, and it gives us a bunch of stuff about x on the triangle on the inside. Well, you can tell that this triangle is connecting midpoint to midpoint to midpoint. That is the mid-segment triangle, okay? And we know that the mid-segments are all half the length of the sides on the outside. So when you're finding the perimeter of a shape, you add together all of the sides. So that means if you add together all of the outsides, that means the mid-segment triangle would take all of those side lengths and cut them in half. So if the perimeter is 100, the perimeter of the mid-segment would be cut in half also. Perimeter of the mid-segment triangle would be 50. That means you take 4x plus 1, 2x plus 5, and 5x. You add all of those together, and it equals 50. All right, that's that right there. Combine all the like terms. 4x, 2x, and 5x come together as 11x. 1 and 5 come together as 6. You subtract the 6, and then you divide by 4. Easy peasy. All right. The test is going to be very similar to this. It always is. Okay. Your test questions are always very similar to these. And if you know how to do these problems, you will have no trouble at all on the Topic 5 test. That's all I've got on this one. Y'all have a good day.